In this video, we're going to look at graphing some more trig functions. So first one we're going to graph is 2 secant of x plus pi. So when you're doing this, you want to be thinking about the reciprocal function that this goes with. So in this case, the cosine function. So secant goes with cosine. And then we just want to think about graphing the cosine function first. So we've got an amplitude of 2. We've got no vertical shift. So let's draw in the midline here. So our midline goes with our vertical shift, which is none. Our amplitude is 2. So we're going to have the amplitude lines going 2 above and below this midline. So up 2 and down 2 from that. And then our phase shift here, okay, so our phase shift is equal to negative pi. And so we want to draw in that phase shift line for our starting axis at negative pi. Then we would want to look at the period, and the period is going to be, for cosine, is 2 pi, and then divided by the b value, which is just 1, so it's going to be 2 pi. So on this graph then, 2 pi is 1, 2, 3, 4, 5, 6, 7, 8 boxes. Divided by 4 gets us every 2 boxes, we have a critical point happening. Okay, so I'm just going to, and then always start that from your phase shift. So then I'm just going to mark off every 2 boxes. Now, when you're graphing, only plot the critical points of the cosine, and then it'll change a little bit for secant. So cosine normally starts at a maximum, so we're going to put a point here. Then it goes down to a middle, down to a min, back to a middle, max, middle, min. And then back from here would be a middle and then to a min. Now, the reciprocal function, okay, where cosine, when cosine equals 0, secant is going to be undefined because the reciprocal of 0 is 1 divided by 0, and that is undefined. So anytime that your cosine or your cosine function is 0, your secant function is going to be undefined. So we're going to put asymptotes at every middle line. So every middle point, okay, there's going to be an asymptote. Now don't get that confused with this phase shift line. Okay, but everywhere you see these zeros, those are going to be asymptotes for the secant function. And I'm just going to lighten this up so that we don't get confused by it. So that was just our phase shift line. So now the other thing that we know is that the reciprocal of 1 is 1 and the reciprocal of negative 1 is 1. So this secant function is going to share the mins and maxes. So these are going to be on the reciprocal graph. And then the reciprocal of like 1/2 would be 2. The reciprocal of 1/10 would be 10. So it's going to be growing from these maxes, okay, towards the asymptotes. And then vice versa, it's going to be going down from these minimums towards the asymptotes. So then the black lines would be our secant function. Next one is the cosecant function. So cosecant goes with the sine function. So let's go ahead and start plotting our lines. So we have no vertical shift, so we're still at the x-axis for that. Our phase shift is pi over 2. Okay, so positive pi over 2. And then our amplitude is 1 since we just have no number written there. So these are going to be at 1 and at negative 1. And then again, I'm just going to make this one lighter so that we don't get confused by it once we start doing our asymptotes. So then we need the period. Okay, and the normal period of the sine function is 2 pi. Our b value is 1. So our period is 2 pi, which again on this graph is 8 boxes. So when we divide by 4, we'll find out a critical point is happening every 2 boxes, starting at the phase shift. Then our sine function starts at a middle. So now we'll just plot these critical points. Okay, so sine goes middle to a max, back to a middle to a min. Okay, then back, min, middle, max, middle, min. Then again, everywhere that we have a middle, okay, the reciprocal of 0 is undefined. So we're going to have an asymptote for our cosecant function. Okay, so everywhere sine was 0, cosecant is going to be undefined. Everywhere sine was -1, so will cosecant. Okay, and it'll go down from those mins. And everywhere sine was 1, cosecant will also be 1, and then it's going to go up from those maxes. So down from these mins, up from the maxes. And that's your cosecant of x minus pi over 2. Tangent's going to be different. So for tangent, we can still start by getting our little lines in here. So we have no vertical shift. So we're going to be starting at 0. And we have no phase shift. So our starting axis is still going to be here. And I am going to make this light again. And then our amplitude is at 3. I'm going to make these ones light too because they don't really do the same thing as they did in the other graphs. All right, then let's take a look at the period. So tangent's normal period is pi, and now we're going to be dividing by 2. So our period is going to be pi over 2. Okay, and pi over 2 is only 2 boxes. Now, tangent splits its period over the starting axis, and it has asymptotes, okay, at those splits. So these 2 boxes, we're going to split over this purple line. So we're going to go 1 box to the left and 1 box to the right. And these are going to be our asymptotes for our graph. Let me get these back to being bold. Okay, so then now you're going to have an asymptote every 2 boxes. So now we're going to just keep having asymptotes every 2 boxes in this case, because the asymptotes are a period's width apart. So tangent splits its period over that phase shift or over that starting axis. Now, tangent also starts, so between its asymptotes, it's at a middle. So halfway between the asymptotes, it's at a middle. And then halfway between the middle and the asymptote to the right, it's at its amplitude. Halfway between the middle and the asymptote to the left, it's at its negative amplitude. So then it's just, this will be hard for me to do on the computer. But it's just going to curve through here and hit. And then I'm just going to, then it'll do this in every one, right? So between here, it'll be at a 0, okay, a 0 halfway between each of these asymptotes. And then halfway to the right at an amp, halfway to the left at the negative amp. So it's just going to repeat this, okay, all the way through. And I'm just going to copy and paste this so I don't have to keep trying to draw it. But it's going to be like this all the way across. Okay, so tangent splits its period over that middle line. And then halfway to the right, it's at an amplitude. Halfway to the left, it's at a negative amplitude. So then let's graph 2 tangent of x minus pi. So the vertical shift, again, there's none. Okay, so our starting axis is still the x-axis. Then our phase shift is at pi, so positive pi. And then I'm going to make that lighter. And then our amplitude is at 2. So the amp, and I'm going to make this light also since these don't act exactly the same way as it did for sine and cosine. All right, so then in this one, our period, again, normally is pi, and our b value here is 1, so the period is still going to be pi. Pi is 4 boxes wide in this case. So that's going to be the width of our asymptotes. And then remember that we need to split that period over this starting axis. So that means 2 boxes left and 2 boxes right. And then that width is the 4 boxes. So then every 4 boxes will have another asymptote. So then just count 4 boxes over until you fill up your graph. So then tangent halfway between the asymptotes is at the middle. Halfway from the 0 to the asymptote, it's at its amplitude. Halfway backwards, it's at its negative amplitude. And then that will just repeat. So middle, halfway between, it's up. Halfway between backwards, it's down. And that will just repeat until you fill your graph. And then you can just fill it up with your branches. So then your branches should be close to the asymptote and then curve through those points. So it shouldn't be a straight line. Okay, it should curve. It should also hit the points. It's just, whoops, a little bit harder for me to do on the computer. But should look something like this as it goes through. Next one, y equals negative sine of x. So our midline here is 0 because we're not adding or subtracting anything outside. We're not adding or subtracting anything inside. So our starting axis still is the y-axis. Period is 2 pi divided by b, so just 2 pi, which is 8 boxes on this graph. Divided by 4 gives us 2 boxes. Okay, so starting from that midline, or sorry, that phase shift, okay, just every 2 boxes. And then the amplitude is just 1. So up at 1 and down at -1. And then sine starts at a middle. Now, since it's negative, it's going to go down to a min and then back up. So it's going to flip over. So then backwards, it's going to go up to a max, then middle, min, middle. And then you can draw in your curve. -2 cosine. So this one is going to have a starting axis at, or a midline at 0. Okay, a phase shift at 0 vertically. Then this one has an amplitude of 2. So it's going to go up 2 and down 2 from that midline. Okay, period is still the same as the last graph. So it's going to be every 2 boxes. Okay, so every 2 boxes, we've got something happening. Since 2 pi is 8 boxes on this graph again. Cosine starts at its maximum, but since this is negative, it's going to start at a minimum. And then it's going to go to a middle, up to a max, down to a middle, down to a min, backwards, up to a middle, up to a max, middle, min. And then you can just come back or draw in your curve. Next one, -2 cosecant of x minus pi. So cosecant, again, goes with the sine function. So we're going to work on graphing the sine function to figure out our key points. So this one does not have a vertical shift because nothing's added or subtracted outside. So we'll still be starting on the x-axis. Then it has a phase shift of pi. So we're going to move our starting axis over to pi. The amplitude here is 2. So we're going to be 2 above the midline and 2 below the midline. And then the period, the b value is 1. So our period is just 2 pi. And 2 pi on here is 8 boxes. So that means every 2 boxes, something interesting will happen. So one of those key points. So I'll just start doing 2 boxes from the phase shift. Now it's also negative here, okay? Sine starts at its middle, so we'll put the middle point. Normally sine would go up to a max. Since it's negative, it's gonna go down to a min instead and then back to a middle. Backwards, it's gonna go up to a max, middle, min, and then just keep following the pattern until you fill up the graph. Now that's for the sine function. Remember, we're doing the cosecant function. So we're going to want to do the reciprocal of those. And so the reciprocal of 0 is undefined. So the cosecant function is going to have asymptotes at all of these points where sine was at its middle. Then cosecant is going to share the maxes and it's going to go up from those maxes. And it's going to share the mins but go down from the mins. And then these curves should go out towards your asymptotes. So there's the cosecant function. And then the last one, we'll do a secant function, and secant is the reciprocal of cosine. So we'll work to plot the cosine function first. So again, we have no vertical shift, so we're not going off of the x-axis. Our starting axis for this one, our phase shift is negative pi over 2. And then our amplitude is 1. And this function is going to flip over since that amplitude is negative. Whoops. Then I'm just going to make this lighter so we can hopefully not get confused by it. Our cosine period is 2 pi divided by our b value, which is 1, so just 2 pi. Again, 2 pi is out at 8 boxes, so every 2 boxes from the phase shift, you'll have a critical value. So then let's plot the key points for cosine, which starts at its max, but in this case, since it's negative, is going to start at its min. So then it'll go to a middle to the right, and then a max, middle, min. Backwards, it'll go up to a middle, and then a max, and then back to a mid. So now you can plot the asymptotes, which are the reciprocals of where cosine was 0. So at all of these points where cosine is at its midline, you're going to have asymptotes for the secant function. Then where cosine was at its max, okay, secant's going to share it, and that's going to go up from there. Where cosine was at its min, secant is going to share and then go down from that min. Okay, then up from cosine's max, down from cosine's min.